We are very excited today of finally being able to share with you our latest technology for machine control system. DAVI is an Italian-based company with design and manufacturing center and headquarters, of course, in Italy, and 2 sales and services branches in the USA and in China. We also have a worldwide footprint thanks to an expansive dealership network. DAVI was originally founded in 1966, and it is now wholly owned and managed by the second generation of the DAVI family. To date, DAVI has over 10,000 installations worldwide in different high technology sectors, such as the mass production, heavy duty, and wind energy industries. DAVI is the largest plate, roller, and angle roller machines manufacturers, both in terms of employees, yearly revenues, and number of machines we can produce every year. We also have over 100 machines always available in stock for very quick delivery. Good morning, everybody, and welcome to DAVI's headquarters. Research and development has been at the core of DAVI's success on the market. Combining the on-ground experience that we made with the know-how and the R&D investment that DAVI made, we brought to the market a new and revolutionary range of control systems. So without further ado, allow me to introduce to you the top of the range of these control systems, iRoll eXtreme. So as you may have noticed in the teaser that we just played, we really redesigned, rethought the console of this control system. This control system has been designed keeping the operator in mind, and also has been designed to be suitable in a heavy-duty environment. The first thing that strikes the eye is actually this very large industrial panel with a very high resolution here. So as soon as the operator will start these control systems, we'll be prompted with the home page. So this is the home page of the control system itself. Let's have a look at what we can find here on the home page. So we have 2 main sub-environments. The first one is the production flow, and the second one is the machine systems flow. On the production flow, we find the job settings as a first working environment. So we just go inside. Inside this environment here, you're going to be able to select the shape of the workpiece that you need to manufacture, and then you will generate automatically the program for this workpiece to be manufactured. So we go back to the home page now, and then once we generated this program, we're going to have all the instruction in this environment here. Of course, we didn't generate any program, so we don't have any instruction here on this screen. And then the last step of this production flow is the work area. So upon entering, we're going to be prompted the machine itself, which will be represented with all the accessories that we have on the machine, which are rendered in 3D in a very high resolution environment. So as soon as you enter this environment here, you're going to notice the smartphone-like feeling of the system. In fact, you're going to be able to move this machine around using your finger. You're going to be able to zoom in and zoom out and also select custom views and custom zooms for the machine itself. You may also notice this dark interface. The dark interface has been designed both for avoiding operator's eye strain and to reduce, even if just a little, the power consumption of the control system itself. Then we go back to the home page and we go to the machine systems environment. So we have the machine parameters you're going to be able to access and change and vary depending on the forming performance that you need to achieve. You're going to have the diagnostic environment where you're going to find everything related to maintenance and the status of the machine itself. And last but not least, you're going to find an environment which is dedicated to the integration with other machines and to the extrapolations of data and information on production and the machine itself, which will then be used by the RTPM for production and maintenance programs. So now we made an overview of the overall functionalities of the control system. Let's dive right in. So thanks to the help of our operator, we're going to roll a cylinder. So first of all, the operator will go into the job settings environment. We'll input the parameters of this cylinder. As you can see here, it's pretty straightforward. The interface is very, very easy to interact with. The touchscreen is very responsive, and this will make the life of your operator easy. So after that, the operator can actually review the program into the program environment. He may make some changes. As you can see here, the programming is actually split into production phases to make it more intuitive for the operator to actually go in and change some settings, change some pieces of the program, and selectively alter the program generated by the CNC. After that, the operator here will launch a simulation of the workpiece being manufactured. As you can see here, there is a complete correspondence between what the simulation is actually rendering and what the machine will be doing next. So once the simulation is done, once the operator is sure that the rolling operation can actually be conducted safely and without collisions, it will launch the program with the actual plate. So for the sake of this demonstration, actually we input an elastic yield which is slightly different from the elastic yield of the actual plate. As a result, the radius that the program calculated and the simulation actually rendered is going to be different from what the plate will actually achieve in terms of curvature radius. So because of that, the operator now is measuring the radius using the DG gauge. The actual read, so monitored radius, will be sent back to the machine. And then, thanks to the radius correction system, we're going to be able to actively correct the program to make sure that we adjust it to the actual elastic yield. So now that this operation is concluded, we're going to restart the rolling operation. And as you will see, the actual forming will be corresponding to the simulated one, and hence the rolling will be completed. But what if you have a cone? So as we all know, cone manufacturing is actually quite challenging, right? So because of this reason, we implemented in a new control system a cone template where exactly as we just seen for the cylinder, your operator will be able to input the main parameter of the cone and execute it completely automated by using the CNC. So as we can see here, the operator now is inputting the parameter of the cone itself. And after that, we're just going to go straight to the working environment where we're going to be launching the program. The operator will then be launching the program itself. And as we can see here, we are executing the first pre-bending. And then after that, we're going to keep rolling the cone against the cone die. And after that, we're going to see the closing of the cone itself. And then the rolling is completed in a very, very straightforward, easy, intuitive way. Not all manufacturers will need to deal only with cones and cylinders as the one we just seen. In some specific sectors, especially where mass production is required, the operators will need to deal with much more complex shapes. So how do we define a complex shape? In general, a complex shape is a shape which requires merging different radius one next to each other. And in general, we call these parts multi-radius parts. So for the sake of this demonstration, we actually took an envelope from the automotive sector and specifically a fuel tank for the truck automotive sector. As you can see here, this part is quite complex. It's actually comprised of different radius, all tangent to each other. And now we're going to explain how this part can be easily manufactured using our control system. So as you can see here, the operator is inputting the part and is constructing the part inside the control system by using the radius and the arch length. So once the part is fully closed, the system will prompt us the required development length and will generate the program suitable for the implementation of this manufacturing process. So of course, on the machine that we have here, it's impossible to realize this part, mostly due to the very, very tight radius this part is comprised of. So right now we will launch the simulation of this part being manufactured on a machine which is actually capable of manufacturing it, which is a dedicated machine which we manufacture for this type of products. And what you will see now is actually this part, this envelope, being manufactured fully automatically in a single pass using one of the rolling line we supply to one of our clients. And as you can see here, the operation is very quick. We can achieve a relatively short cycle time, which is also simulated in the simulation environment. So now that we completed the presentation on the fully automated board, let's now focus on the heavy-duty manufacturing. So as we all know, whenever heavy-duty plates have to be manufactured, of course we're talking about a very expensive, very heavy, very thick plates. So those plates, the operator handling these plates, will very, very rarely manufacture these plates in a fully automated mode. These manufacturers will need to rely massively on their operator skill. So for these manufacturers, we actually included in our new control system enhanced rolling features dedicated to an assisted manual operation. So what are these features? So first of all, we all know that these very thick, very large, very expensive plates are typically manufactured in multipass. So what we decided to do is we decided to include in all our control systems the multi-pass programming feature, which will generate automatically a program starting from the inputs, as we just seen for the cylinder, for example, but will generate a program which will manufacture the part in multipass, something that normally would require a very, very long time to the operator to do. And in addition to this very, very interesting and innovative feature, we also included what we call the Apple shape calculator. So of course, every time we have to deal with these very expensive plates, most of the time, depending on the sector, we're going to have to re-roll. And re-rolling, we all know, requires a specific shape to be achieved. So before re-rolling, we actually need to form the cylinder, the can, into a specific shape, which is either an apple shape or a heart shape, depending on whether the pick is out or in. We introduced this very innovative calculator tool within the control system, which will allow the operator to automatically calculate the correct apple shape based on the tolerance which has to be achieved at the end of the re-rolling process, so the target tolerance. And also, the program will be adjusted based on the type of beveling present on the machine. So to do so, the operator, as you may have seen in my background, actually moved to a very large machine, which is a 3,000 tons capacity machine, where actually we placed a 135 millimeter thick can, which was obviously pre-rolled, and that's corresponding to the plate he input using the Apple calculator tool. So as you can see here, we introduced in this new control system all these assisted manual mode, which will really boost your productivity when dealing with heavy-duty, thick, heavy plates. Using more and more automations, corporations can perform processes with limited to no human intervention. This, of course, greatly enhances efficiency and productivity, and eventually their competitiveness on the market. Automation in industrial settings typically use a centralized control systems called Manufacturing Execution System, or MES, which processes a vast quantities of data to manage equipment and processes. Industry 4.0, also known as the fourth industrial revolution, merges automation and these big data sets. In this way, any machine on the production floor is fully integrated to the benefit of improved production efficiency. In this regard, all our control systems guarantee full integration to the plant network thanks to OPC UI connectivity technology. Moreover, we developed a dedicated control environment called Automatic Mode Production Report, where data and information on the machine and productivity can be gathered. This data can then be used within the real-time performance management, generally referred to as RTPM, to create high-value maintenance and production strategies. We all know the importance the maintenance plays in keeping the equipment at the appropriate performance level, as well as increase its durability. We also know how large the impact of maintenance cost is on the so-called total cost of ownership of any manufacturing asset. For this reason, we created a dedicated working environment where it is possible to actively monitor the machine status, as well as at the same time help the operators conducting their predictive maintenance. This is to achieve what we like to refer to as failure-free machine. So for the sake of this presentation, we artificially created an issue to the machine so that we can show you what would be the process in case of an alarm popping up in a machine itself. So as we can see here, the operator is receiving an alarm on his interface, and now he will open the dedicated environment of the control system itself. And after that, he will notice there's actually a malfunctioning in the pressure transducer. So after that, the operator will use the smart glasses that we actually witnessed earlier during the teaser of the control system itself. And then using these glasses will identify way more easily where the problem is within the hydraulic unit of the machine. We'll then move to the hydraulic unit itself, and as you can see here, we'll fix the problem by reconnecting the pressure transducer, and after that the problem is solved, and the alarm goes away. Of course, the same tool which here we used for, let's say, solving a problem during the operation of the machine can also be used in the very same way to help the operator connect with our customer service, either for troubleshooting or for ongoing training. So again, with this new control system, we are introducing new innovative features to the market, and one of those is actually these smart glasses. So today we focused on the top of the control system range, and we really hope you appreciated all the exclusive and unique features that we showcased. Of course, depending on the level of automation required by your company, we also have other packages available. If you want more information on the company or the control system, please visit our website, davi.com, and get in touch with our sales managers. Thank you all for your attention, and see you next time.